Hey everyone, welcome back to stormwind.com. This is Anthony Sequeira, and this is session number 5 of 8 sessions in our TSHOOT class. And you saw what we had up at the beginning of class. That's right, it is a topology diagram, and you have had time to go ahead and make your own copy of this diagram. That's really going to help you as we go through and troubleshoot this particular topology. Remember, we said we wanted to start this particular class with a real-world troubleshooting example. And what we need to do in this particular example is we need to make sure PCA, PCB, and PCC each have full connectivity with each other. We note that these particular devices are in different VLANs. We've got PCA and PCB, both participating in VLAN 10. And then we've got PCC that is in VLAN 20. Now, one of the things that you should definitely do when you're doing a troubleshooting example like this one is before you do anything, before you choose a particular strategy, before you really start getting into your mental planning out of what you're going to do, I think it'd be very worthwhile just to look at the particular topology and think about, the technologies involved and what could go wrong. I mean, obviously, we need this VLAN 10 properly set up here, both on the PC and on the switch port. We need the appropriate VLANs on these switches. We need to do routing on these switches somewhere because we have different VLANs that are going to require connectivity. Here we have Ether channel. What could go wrong there? We've got all of our port assignments. So you really, and by the way, this better be a trunk link as well, right? I'm assuming this better be a trunk because we're trying to span VLANs across switches. So you just start getting kind of a mental inventory, if you will, of what technologies are going on here and what could go wrong. Yeah, what could go wrong? The other thing you would want to do, obviously, is you would want to go to these devices and you'd want to make sure that nothing works. Yeah, you'd want to make sure that you truly do have problems, right? So we'll start by verifying we have problems. Here on PCA, let's first try and communicate with somebody that is in our own VLAN. Let's see if we can communicate within our own VLAN. And we can. Okay, so that's interesting. We can communicate within our own VLAN. Okay, good sign. Now, can we communicate with someone that is outside of our VLAN? And I'm guessing that's going to be a resounding no, but let's see. Aha, so there is our problem. Now, this is pretty interesting, right? Look we get a huge clue as to what is going on here, don't we? PCA can communicate just fine with PCB. So does that tell us quite a bit about what's going on with this topology? Yeah, it does. Let me get a different colored pen. I'll get a different colored pen here. Let's do green. And so we kind of know that this is all set. This must be all set. VLAN 10 must be here. We must be trunking. This must have VLAN 10. This and this is all set up correctly. I mean, we just learned quite a bit that's actually right with the topology. And we can mentally eliminate quite a bit. Now let me turn to our audience here. Matthew, I know you're here with us. Matthew, what do you think? Where would you start? What do you want to do? I mean, we now know the scope of the problem pretty darn well. PCA cannot communicate with PCC. I suppose we could go over to PCB and try and communicate with that device. So let's do that. Let's go over to PCB. By the way, this is PCB. There we go. And let's try a ping of 10.20.20.4. And let me show you this. Okay, so sure enough, neither the PCA or the PCB has connectivity to our PCC machine. Okay. Well, yeah, what we want to do here is we want to choose a particular strategy and we want to go for it. We really want to and Matthew's got a great point too. Matthew says, all right, look, I want to know where is the routing? Where is the routing? Okay, so Matthew is suggesting, I love it, that we kind of start with a divide and conquer then. Yeah, Matthew's suggesting, hey, look, there needs to be routing here. So switch 1 or switch 2 has to be routing or we're in big trouble. I love it. Matthew, what can we do? What can we do to confirm routing? What would you do? It's got to be switch 1 or switch 2. What would you like to do? Okay, Matthew says show IP route. I love it. I love it. Yeah, nothing like being direct and to the point, right? Let's go over to switch 1 and do a show IP route. Uh-oh. The ICMP redirect cache. When we see this, it means we are not routing. We do not have routing enabled on the device. Let's go over to switch 2. Show IP route. Uh-oh. Same thing there. So we check our routing documentation. We check our documentation, and this device right here is supposed to be our layer 3 device. Switch 2 is supposed to be our layer 3, our multi-layer switch. So Matthew, awesome job. Awesome work. We're going to go to this device here, and we're going to say IP routing. And we're going to turn on its routing capabilities. And I'm going to do a show IP route. And we see now, aha, it has awareness of the directly connected subnets. And it knows that these are in VLAN sub interfaces. Sure, these are in VLAN, not VLAN sub interfaces. They're in VLAN interfaces, otherwise known as switch virtual interfaces. Great stuff. So we have switch virtual interfaces here for the 2 subnets that cannot communicate. That is awesome stuff. Okay, let's see. I guess we are at a point where we've made a change in the exam environment. You know, if you were doing this in a simulation in the exam, you would save it. Although remember, in the exam environment, we are not responsible for fixing anything. That's kind of cool. You just got to find problems and report them. You're not actually making fixes in the exam environment. So anyways, we'll save our change because in our example here, which is going to be more difficult, more real world than what we see in the exam, we are going to actually save our changes. We are going to fix stuff. All right, now I think a good thing to do would be go over to PCA and rerun our test. And unfortunately, we are not out of the woods yet. Now, we're going to rerun our test, and we do not have the inter-VLAN connectivity that we are looking for. Yikes. Matthew, what should we do next? I love your divide and conquer approach. We found a major problem. What do you think, Matthew? What would be our next kind of approach here? It would appear, and I'll go ahead and peel back the curtain and let you know that there is indeed more than one problem here. So we fixed a major problem. We gave these devices the ability to communicate between VLANs by adding routing to the mix. But unfortunately, after solving that problem, we still don't have connectivity. Well, yeah, this is really a time at which it would be just fine for you to go into a kind of trace the path and bottom-up troubleshooting approach. Yeah. And what's interesting about this is you could do it really, really quickly because you know, for instance, that layer 1 and layer 2 is just fine on PCA. Yeah, isn't that interesting? We know layer 1 and layer 2 is fine on PCA. So we could jump right to layer 3 there, couldn't we? We could do show IP route. And we could jump right to layer 3, and we could make sure that this device has routing knowledge to get to VLAN 2. And sure enough, it does have that knowledge thanks to a default static route pointing to 10, 10, 10, 100. I can jump over to Cat2 and do show run interface VLAN 10 and make sure that that default gateway address is correct information. So now I've confirmed on PCA layer 3 as well. So PCA is in great shape from a layer 1, layer 2, layer 3 perspective. I'm comfortable jumping over to switch 1. Yep, I'm comfortable jumping over to switch 1. We know this interface is fine because PCA could communicate with PCB. So let's go ahead and investigate further switch 1's configuration. So we'll go over to switch 1. And what command would you run here, Matthew? What additional verification commands would we be interested in running on switch 1? I mean, one of the things that we know must be in good shape is the interface that leads to PCA must be in good shape because this was proven when PCA could communicate with PCB. What else might we run on switch 1 from verification command, from a verification command perspective? Matthew's typing in his response right now. Awesome stuff. Thank you, Matthew. All right, Matthew says, hey, I'm kind of drawing a blank here. All right, no problem. Let me give you some assistance here. We are attempting to communicate between a couple of VLANs, aren't we? VLAN 10 and VLAN 20. Do those VLANs need to be populated on all these switches? Yes, they do. So one other thing we would want to check at layer 2, right, for these devices is a consistent VLAN database. Sure. And really, a simple way to do that is show VLAN brief. Show VLAN brief is the way you would do that. And look at this. We discover that there is no VLAN 20 on switch 1. Wow. No VLAN 20 on switch 1. Let me do a show VTP status. And we are set up as transparent in a domain called TSHOOT. Let's check with switch 2's configuration. Show VLAN brief. It has both VLANs. And let me do a show VTP status. And it is transparent in the TSHOOT domain. So it looks like in our environment, we are not to use VTP. Both devices are set to transparent, but we need to make sure VLAN 20 is on switch 1. I made a change. Let me copy that change. And let's go ahead and test connectivity now. We've got the VLAN properly populated on both of VLAN 20 on both of the switches. Notice I'm doing a ping here with a repeat count of 10 because there will be some convergence with spanning tree protocol that needs to take place now that we've changed that layer 2 architecture. Nothing. Let me repeat that ping because we're running classic spanning tree in this example, unfortunately, and that can have some pretty serious convergence times. All right, well, we've still got problems here, still got issues. So let's go over and take a look at switch 2. I think we've confirmed the layer 2 infrastructure on switch 1. We found a problem there. No VLAN 20 in its database. We corrected that. Let's move over to switch 3. This is the device that's doing routing. And let's scrutinize its configuration. In fact, I noticed something a moment ago when we did our show VLAN brief command to make sure that VLAN 10 and VLAN 20 were there. Look at this. VLAN 20 is not assigned to any interface. VLAN 20 is there, but unfortunately, VLAN 20 is just there doing nothing. What is the assignment supposed to be? The assignment is supposed to be on 0/4. Wow. So there is yet another problem in this troubled layer 2 infrastructure. We need to go to 0/4 and say switch port mode access, switch port access VLAN 20. And you know what? While we're at it, we'll no shut that interface, just in case it's shut down. Okay. So it looks to me like we've got PCA good, switch 1 good, switch 2 good, PCB we know is good. Let's check layer 3 on PCB. We could communicate with PCA in its own VLAN, but let's just make sure it is set up properly for inter-VLAN routing. Let me do my copy run star over here. We made some changes. Let me go over to PCB and do a show IP route. Yep, it's got its static default route configured beautifully. So we do indeed know for a fact that PCB is in good shape. So I guess the only thing left for us to check is PCC. Yeah, it's the last device in this follow the path troubleshooting approach that we are doing. And let's go to it right now. How about we do I like the show IP route command. Oh boy. That doesn't look good. That doesn't look good on R4. There are no entries in the routing table. Why no entries in the routing table? Well, if you do a show IP interface brief, we learn that we have a shutdown interface. Wow. So let's get in there and no shut that interface. And let's check the routing table now. We've got our static default route pointing to the default gateway on switch 2. It looks to me like we're going to be in really good shape now. So we save that configuration. We go back over to PCA and we rerun our ping test. And after a couple of failures in packets, we finally get convergence, and sure enough, we are communicating inter-VLAN now between these devices. Wow. And that is obviously much more difficult than any ticket that we might face in the exam environment, because there was all kinds of errors in this particular topology. In fact, let's quickly review the errors that we found. And I say we found, and I should be a bit more fair, because the first one we found, we didn't find it, Matthew found it. Great job, Matthew. And that was IP routing, right? I'll just say no IP routing. Yep, no IP routing on switch number 2. Great work. Another problem, there was no VLAN 20 on switch 1. Another problem, fast Ethernet 0/4 was not in VLAN 20. Another problem, 0/0 on PCC was in the shutdown state. So we had 3 major problems here in the, 4 major problems here in the topology. Very, very simple fixes. Yeah, very simple fixes, and they weren't all that difficult to find once we knew to look for them. But boy, oh boy, taken together, this was pretty messy. So great work in the live troubleshooting example here. And that reviews, obviously, most of the technology-based troubleshooting discussions that we needed to review from previous lecture sessions.